Remember the days when we used fire to heat up our homes, light up our houses, and was used for cooking? Well, time has changed. Now we use electricity to do all that and more. We have an example here where our electrical panel distributes energy and electricity which goes to our light bulbs, our heaters, our power tools demonstrated by Jacob, and our tablets. And did you guys know that the average consumption of energy used by a tablet is around 11.3 kilowatt hours per year? That's really cool. Electricity is a form of energy that is primarily made up of electrons. There are things that have high conductivity, and those are called conductors. A great example of that is copper wire. Then there are things that have low conductivity or no conductivity at all, and those are called insulators. A great example of that is glass or rubber. In order for copper wire to have a higher conductivity, the metal is required to be thin because it has less resistance. There are two equations that are used to calculate electricity. One of the formulas is Ohm's law, which is V equals I times R, or voltage equals current times resistance. The other is the power law, which is power equals I times V, or power equals current times voltage. V or voltage is measured in volts. I or current is measured in amperes, or for short A. R or resistance is measured in ohms, and P or power is measured in watts. And now we're going to do some math using these equations. So our first question is, a 15-watt motor draws a current of 1.5 amps. What's the voltage? So first, what we do is we figure out what 15 watts is. And that is power. And then we figure out what 1.5 amperes is, or A. And that is I. So we have to find V. So in the equation, it is power equals I times V. So what we do here is we divide I both sides on both sides. So we get V equals P divided by I, or voltage equals power divided by amperes, or current, whatever you want to call it. So it would be V equals 15 watts divided by 1.5 amperes. And that would calculate to be 10 volts. And here is the answer, 10 volts. Let's make another problem up, but this time let's use Ohm's law. So we have 6 volts outlet, a 6-volt outlet that is connected to a lamp. And there's a current of 2 amperes, or 2 A's, flowing through it. So we have to find the resistance, which is unknown. So according to the equation, it is V equals I times R, which I equals A, or 2A in this case. And the V equals 6 volts. So what we do is we divide I on both sides to get R by itself, which is R equals V divided by I. So we just plug in the numbers, which would be 6 volts divided by 2 amperes, 2 A's as I like to call it, which would equal R. So 3 ohms is our final answer.
It's a really interesting thing to learn about, but it is also a very deadly and very dangerous thing. When you are outside, please stay in your car. That way, if lightning strikes your car, you won't get injured. But do not go outside and touch the metal. You might get electrocuted. Do not stay under a tree because the trees are very tall, and those are the easiest ways for negative energy from the clouds to get to the positive energy of the ground in the form of lightning. Do stay in your house. Don't stay at your front porch watching the thunderstorm come by, because if you do, there is a higher chance for you to get hit by lightning since it can travel at high speeds. It don't matter if it's 20 miles, 30 miles, 40 miles away. There is a higher chance for you to get hit. Stay clear of any water. Do not take a bath, because if you do and the lightning for some reason hits like a metal tube, there's a high chance that water could be connected to your house, and if it's made out of metal, which it should be, it could conduct to the water and electrocute you in the tub. So please, stay away from water, stay away from trees, do not be out in the open, stay indoors, and read a book.